225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent. We've seen what happens when the plates move apart. But when they crash into one another, the effects are even more dramatic. The collision of the Earth's plates is responsible for the most spectacular mountain ranges on our planet. To see how they're created, I've come to New Zealand's South Island. These stunning peaks run 500 kilometres along the west coast, forming a dramatic spine down the island.
According to Maori legend, these mountains are made of the petrified bodies of 4 gods who got stranded here on a canoeing trip to Earth. As they were attempting to return to the heavens, a big storm blew up and capsized the canoe. They climbed on board and waited for someone to rescue them, but no one came. As time passed, they slowly turned to stone. As far as geology goes, there's a slightly different explanation. It may not be as romantic as Maori legend, but it's every bit as epic.
What was to become New Zealand was once a group of scattered islands. The collision of the Pacific and Australian plates forced these islands together, creating the familiar outline of New Zealand that we know today. Along the collision zone, the land was buckled and a line of mountains rose up.
New Zealand's mountains are around 5 million years old. That may sound ancient, but it's just a geological blink of an eye. Yet, even in this short time scale, these peaks have grown into giants.
All the world's great mountain ranges form in this way when continents collide. You can really get a sense of how the surface of the Earth crumples when you look down from space. These are the European Alps, the South American Andes, and the Himalayas of Central Asia. They're all relatively young, born out of recent collisions between plates. Sometimes you can actually see their growing pains. Earthquakes are a horrific force of destruction. Entire cities can be wiped out at terrible human cost. But this is what happens when our planet builds its great mountain ranges. In October 2005, a devastating earthquake hit the western Himalayas in northern Pakistan. The area around the town of Muzaffarabad was completely razed to the ground. But satellites measuring the height of the surrounding land before and after the earthquake revealed that something else had happened as well. The red and yellow colours show how the hills to the east of the earthquake's epicenter had actually risen as much as 5 meters during the earthquake. This process, repeated thousands of times, has helped build the Himalayas into the greatest mountain range on Earth. And it's just as well that the Earth's inner heat continues to push mountains up. Because huge though mountains are, they're continually under attack. Given enough time, there's a force that can completely destroy them. It might seem unlikely, but that force is nothing more than water. Ironically, mountains create the very rain that attacks them. They're high enough to disrupt the atmosphere and create their own weather. The higher the mountains are pushed up, the higher the air is forced to rise to cross them. So the air cools and condenses into clouds, which produce rain. And it's surprising just how effective the power of water can be. It's only when you're fighting the rapids that you can begin to understand how powerful a river can be. This gorge is hundreds of meters deep, and yet it was cut by the river, relentlessly wearing away at the rock, and it's still getting deeper. Rivers don't just erode the rock, they also carry it from the mountains to the sea in the form of silt. It happens on a massive scale. In South America, the Amazon carries away over 2 billion tons of the Andes every year and deposits it in the Atlantic Ocean. And on the Indian subcontinent, the Ganges River that starts high in the Himalayas grinds away around 1 billion tons of rock every year, dropping it 3,000 kilometers downriver in the Indian Ocean. If it wasn't for the movement of the plates building new mountain ranges, water would eventually erode away all the land on our planet. It's hard to imagine, but if the plates should ever stop moving, our planet would become a water world. It may take an unfeasibly long time, but eventually the land would be worn down and washed out to sea, and Earth would be covered in a vast ocean several kilometres deep. So it's thanks to the collision of the plates continually pushing the land up that we still got terra firma to stand on. Our world is constantly reshaped by a never-ending battle between the Earth's inner heat that pushes the land up and the forces of erosion that wear it down. But the Earth's inner heat has made a profound difference to our planet in another way. Perhaps in the most important way of all. It began around 4 billion years ago. This is Rota.